In this segment, we're going to talk about trends on the HR diagram. Let's draw a general HR diagram. Luminosity of stars are on the vertical axis relative to the luminosity of the sun, and luminosity always increases in the vertical direction. Now on the horizontal axis, we can put color, we can put spectral type, or we can put temperature. Let's put temperature. Temperature increases to the left, and temperature is written in units of Kelvin. So here we have our first two trends. Hot stars are on the left side of the diagram. Cool stars are on the right side of the diagram. So this is one trend, going from cool stars on the right to hot stars on the left. Another trend is the luminosity. So dim stars are at the bottom and bright stars are at the top. So we have our first two trends. Temperature increases to the left and luminosity increases in the vertical direction. Now let's look at the trend of radius, or how big the star is. Radius increases from the lower left to the upper right corner, and it increases everywhere across the diagram. So if I compared a bright blue star to a dim blue star, which star is larger? Well, how we determine this is we draw perpendicular lines to the black lines, and I'll draw them in gray. So every star that's along a gray line is about the same radius. So since the bright blue star is to the right or on a different gray line compared to the dim blue star is on this line, whereas the bright blue star is over here, more to the right, then the bright blue star is the larger star. Let's add in a bright red star. Now, which is the larger star? Is it the bright red star, or is it the bright blue star? Well, since the bright red star is further to the right in the diagram, it is the larger star. What about a dim red star? Let's compare the dim red star to the dim blue star. Which one is larger? Actually, let's take a look at where they appear in their lines. So here is the blue star, and the red star is more to the right. So the dim red star is actually larger than the dim blue star. So remember that everywhere on the HR diagram, radius increases to the upper right. And that finishes our third trend in radius. Now let's look at the trend in mass. To look at the trend in mass, we need to draw in the main sequence. So the main sequence is actually a curve. I'm just going to draw it as a fairly straight line. It's actually a thickness, like a bar. And we want to know, how does mass vary on the HR diagram? Well, I cannot tell you how mass varies on the HR diagram. I can only tell you how mass varies along the main sequence. Mass increases along the main sequence from lower right to upper left. So low mass stars are down at the bottom right, and high mass stars are up at the upper left. So if I compared a small red star to a large blue star on the main sequence, the large blue star has the higher mass compared to the low red star. If I compared a supergiant to a red star on the main sequence and asked you which is the larger mass star, your answer should be, I don't know, because the supergiant star is off the main sequence. So I only know the trend on the main sequence, not everywhere on the HR diagram. So you can't answer questions about anything above the main sequence or below the main sequence. You can only answer questions about mass on the main sequence. Let's look at the trend in number. How does number vary on the HR diagram? Once again, we have to draw in the main sequence. I can't tell you how many numbers are above or below, or the trends above or below the main sequence. I can only tell you the trend along the main sequence, and that trend is from upper left to lower right. So there are more stars located down at the bottom right and fewer stars located at the upper left. So if we populated the main sequence with dots, with each dot representing a star, you'd have fewer of them at the upper left, and you'd have a lot more of them down at the bottom right, with fewer and fewer in between. So you have the fewest ones at the upper left, and you have the most dots down at the bottom right. Let's look at the trend in age. Where will we find the oldest stars on the main sequence, and where will we find the youngest stars? Once again, we have to draw the main sequence in. I can't tell you about the trend in the age of stars above or below the main sequence, so I can't tell you anything above or below, but what I can do is tell you along the main sequence. And so we want to draw a line that goes from upper left to bottom right. So the oldest stars on the main sequence are down at the bottom right, and the youngest stars on the main sequence are at the upper left. Now what I mean by youngest and oldest, you want to think of these stars as like adult stars. They're all adults, but the 20-year-olds are up at the top, and the 100-year-olds are down at the bottom. They're all adult stars. So the stars are fully developed, they're normal stars, just the youngest ones are at the upper left, and the oldest ones are at the bottom right. So if we compared ages to the ages of adults, a 20-year-old would be a young adult, and a 100-year-old would be an old adult. The youngest fully developed normal stars are at the upper left, and the oldest fully developed normal stars are down at the bottom right. So let's look at an HR diagram from your textbook. So let's look at the trends from a diagram from your textbook. As you can see, temperature increases to the left. Luminosity increases in the vertical direction. Absolute magnitude in the visual band increases downward. Radius increases everywhere from bottom left to upper right. Now let's talk about trends along the main sequence. We have mass, and mass increases from bottom right to upper left. Number increases from upper left to bottom right. So there are more red dwarfs than violet dwarfs. Age increases from upper left to bottom right. The oldest stars are the red dwarfs. The youngest stars are the violet dwarfs. So let's look at the sun. The sun is a main sequence star. It's sitting on the main sequence. We can read off its absolute magnitude in the visual band, which is about a 5. And we can read off its luminosity compared to the luminosity of the sun, which is of course 1. We can take a look at its spectral class, which is a G star, and it has a subclass of 2. And we can also look at the temperature. Now find Polaris on the diagram. Here is Polaris. Compared to Polaris and the sun, is Polaris larger or smaller? Your answer is that it should be larger. What about luminosity? Is the sun more luminous than Polaris, Your answer should be no. Polaris has a higher luminosity than the sun, so therefore Polaris is brighter. What about temperature? Which star is cooler? Well, if you compare where the sun is and you compare to where Polaris is, you see that the sun is to the right of Polaris, so therefore the sun is a cooler star. Now find Spica A on the HR diagram. Here it is. Compared to Spica A, is Spica A older or younger than the sun? Your answer should be that Spica A is younger. Spica A is more in the upper left direction, therefore it is younger. Comparing Spica A and the sun, which star is more massive? Since the sun is more to the right on the HR diagram compared to Spica A, it is going to be the more massive object. Comparing Spica A and the sun, which star is redder? So redder means it's going to be more towards the right side of the HR diagram. If I said bluer, that would be more towards the left side of the diagram. Well, the sun is more on the right side of the diagram compared to Spica A, so the sun would appear more redder than Spica A. Spica A, as you can see, is going to be in the indigo-violet region. So this gives you some general trends on the HR diagram.